So in the previous unit, we looked at software engineering. In this unit, we're going to get into C Sharp as the language. And we're going to try to compare it to other languages, understand some of the terminologies and the history, and just kind of wrap our heads around C Sharp because it's really a big topic. There's a lot of things that the language does. It's impossible really in this course to go over everything. In the course, I'm really trying to hit the highlights and really show you how it works and start you off in the right direction. But there's literally so many things you can do with C Sharp because you can make desktop applications, augmented reality, virtual reality, games, web servers. You can make pretty much anything you want with C Sharp. So, and those different types, and you can program it in object-oriented style. You can do functional. You can do some, and if you're coming from a background of PHP, there's so many, or even Python, there's so much more stuff you can do with C Sharp. And if you're coming from a background of Java, you're going to find that C Sharp, I think, is more of a productive language. It's easier to use, but there's some concepts that's going to come back, and we'll get into that as we start to compare the language. So let's just talk about C Sharp a little bit. So I like to say C Sharp was inspired by C. So we'll talk about C in our language comparison. And C Sharp is object-oriented, but they've also added functional programming capabilities. And with that, you have what's called anonymous functions. And basically, it's that you can sort of think with functional programming, functions become have the ability to be passed around like you would pass variables around in other languages. So you can, with functional programming, it's kind of a different programming paradigm than object-oriented, but it's sort of similar. We're not really going to focus on functional programming. We're really focused on the object-oriented methodologies with C Sharp. The other thing is that C Sharp is really component-oriented, or think DLL or assemblies. That a DLL is a dynamic link library, which we're going to get into the future. But the gist of it is that you're modularizing your application into small reusable chunks. Okay, so C Sharp really promotes good software architecture because it really wants you to not repeat yourself, as we talked about in the sort of software engineering clean coding idea, and it makes available to the programmer a lot of benefits of not repeating themselves by being able to easily reuse libraries and publish them. So what we want to do is really think of how C Sharp is a component-oriented language. It's object-oriented, but it really sort of leans towards development of small reusable software modules, or in the case of this is DLLs or DLL files that are dynamic link files or dynamic library link. And we're going to want to we're going to go up to here, and I'm going to want you to read this article on Medium here. It's really talking about how Microsoft, we can go there right now, how Microsoft open sourced the C Sharp compiler. And you really want to read this article because it is a major change. It really talks about a major change in Microsoft when they embraced open source. But the other thing about it is that there's some terminology that you're going to want to really understand, what we'll get into a little bit later, about the .NET framework versus .NET Core, and it'll help you really understand when you're reading documentation and when you're reading tutorials or when you're asking questions on Google. It's going to help you understand what to ask, okay? Because we'll get back to .NET Core um, in a little bit as we start to talk more about the C# library. But basically, um, Microsoft had a project Roslyn, and I'll fix that real quick. And it really started releasing, and Roslyn is the code name essentially for the project to open source C# and the what we eventually called .NET Core, which is .NET Core allows for cross-platform applications, and we'll talk about that a little bit in a little bit. But basically, the thing to know is that today C# with .NET Core is open source, and that C# with .NET Framework, if you see .NET Framework, is not open source, and I would say an old model. So we'll get more into that later. So if we go here, and let's talk a little bit about C# itself. So C# is a high-level object-oriented programming language that is also built as an extension of C. It was developed by a team at Microsoft led by Anders Heggelberg in 2002, and it's based on the .NET framework, but its backbone is still clearly the C language. So we'll talk a little bit about the C language and to understand where the similarities or where it comes from. So one of the things you have to understand is that C# compiles into bytecode rather than machine code. So we're going to look a little bit about what bytecode and machine code is in a second so we understand it. And that the bytecode executes on a virtual computer that translates it into machine code on the fly. The virtual computer, which we'll get into in a minute, we'll talk more about it. It adds garbage collection, initialized variable checking, and type checking capabilities to the base C code. So this is, if we look at bytecode versus machine code, this is a concept we should understand when we're talking about some of these languages, is that basically bytecode is an intermediary code that is used to sort of set an application set of instructions to generate machine code. So basically, machine code is a computer programming language consisting of binary instructions which a computer can respond to directly. In contrast, bytecode is a form of instruction set designed for efficient execution by a software such as a virtual machine. Hence, this explains the fundamental difference between machine code and bytecode. So the gist of this is, I want you to read this article on the difference between machine code and bytecode, and you can think of the machine code how should I put this? The machine code essentially is instructions that can generate bytecode. So bytecode is what actually runs on the computer. So when C# compiles, it turns it into bytecode so it directly can run on the machine. And we'll get a little bit into this because it's a little complicated. So with C#, what we have is basically it was brought around in version 1.0 by Microsoft and Anders Heggelberg. And this was really like where we had like .NET framework and C Sharps just started to get introduced, but it wasn't open sourced. And where we sort of start to develop is that they gradually started to improve the language with adding more functionality to sort of bring it up to parity with languages like Java. And then in 2015, that's whenever uh, Roslyn really came out. So they announced it in like 2014, but it came out with C Sharp 6.0, which was where we had .NET Core. And it added some features. And then in 2016, we got tuples and pattern matching and decomposition, and we have some other improvements. And then what we have while we're making the course, just to understand, is that we got C Sharp version 8 that has a lot of new features, and you can read about it in this article. But it was released in April 2019. So we're with Visual Studio 8 2009. I mean Visual Studio 2019 that we're going to be using. This is the version of C Sharp that we're going to be have available. But generally, what we're doing is going to be compatible with the previous versions of C Sharp because we're not using most of the really advanced features that it has. As far as like what's been added with tuples and all this other things, we're really going to be looking at the introduction and then saving some of those things for the intermediate course. So let's talk a little bit about some of the terminology that we're going to hear about and how things work in C Sharp and what they are, and these abbreviations that with CLI and CIL and CLR and framework and core what, and just what is all of this. So this diagram will help you understand a little bit about the relationship between CLI, CIL, and CLR, which are how basically C Sharp and other .NET languages, supported languages, are run. So, and how these acronyms really relate to each other. So here, what we're gonna say, look at how on the right here we have C Sharp. Okay, so let's step back a little bit and let's talk about what this common language infrastructure idea is so that within this box here, the perforated box, you have the common intermediate language, or CIL, the common language runtime, which is basically the machine readable code to be executed on the platform. So this is a template. So basically what happens whenever we're making a C Sharp application is that the C Sharp has a compiler, and that compiler is going to turn the C Sharp application into a form that is usable by the common language infrastructure system or specification, which we'll talk about in a second. So because of this, what happens is that C Sharp, VB.NET, and J Sharp can all have their different compilers, but that these different languages can produce modules that each other can use. So and that they all can go into essentially like a virtual machine, which is the common language infrastructure that allows these different languages to run on different platforms such as Windows, Mac, and Linux. Okay, so with C Sharp, with Roslyn, when they open sourced this was sort of and they came up with this common language infrastructure specification that is a public specification that is registered with ECMA International. This is a sort of open sourcing the process and to develop cross-platform applications using .NET technology. So this process is sort of, if you imagine, it's like a expanded version of Java. So if you're familiar with Java at all, you have like the Java virtual machine, which is functioning sort of like the common language infrastructure, but in the case of Java, it's only for Java and the Java code to run on the Java virtual machine. So you'd have like Java, the compiler, and then Java virtual machine is running it. But with the Microsoft approach, they have multiple languages: C#, VB.NET, F#, J#, whatever languages that are supported. Allows developers using different languages to develop cross-platform applications more easily. So, you know, a lot of times each language is invented for a specific reason, and it helps to be able to share those languages and run them on the same infrastructure as other languages. So, a little more detailed look at C# and running an application. You can kind of see this is sort of the workflow that we have. So we have the C# source files. Okay, so like imagine that in that box right here, this is what you're going to see in whenever we get into Visual Studio. This is your solution, and you have resources and references, which are other libraries, and resources, which are files that you might use. And this is the C# code, and all of these are packaged up in the compiler. And then in that compiler, we can either create an executable, which can be a self-contained executable that can run without having the framework compiled with it, or we can produce a DLL, which is a dynamic link library, and that's sort of you could think of that as a component or a module that you would use inside of another program. So we're going to get more into DLLs later, but basically, whenever we have our first couple units, our first unit is going to be setting up the ID and everything, but the first coding unit is going to be to produce a DLL, and then the third unit is going to be to produce an exe that uses our DLL. So you can see the relationship between DLLs and executables. So DLLs are really libraries, and they can be executed with the command line, but really if you want to distribute them in a cross-platform way and have them in an application, you're really going to want to bundle them and produce them as executables that can run on Windows or other platforms, because now .NET, like I've mentioned before, .NET now runs on Windows, Mac, and on Linux systems. So once that exe or DLL is produced, then what we have really is, and this is a little bit older, but we have .NET Core here, or you could say .NET Framework, depending on, we'll talk about the differences in here in a second. But this is the common language runtime, which we mentioned before. And this is really, if we go back to here, this is the section that is basically taking and compiling to machine readable code and integrating the .NET framework if it has it available. Okay, and then that code is converted to native machine code as the output of this process, and then run on the machine's operating system. So if we want to know a little bit more about this, we can take a look at what is the common language runtime in C#. So we can what you kind of get here, just as the, and we'll talk about it a little bit more whenever we get to Java, but basically you can think of sort of the .NET Core, the .NET Framework, sort of like the Java virtual machine, and that the but the difference here in a way versus the virtual machine is that it's possible to distribute an executable file or distribute a running application to multiple platforms within a universal app produced with .NET Core um, that can run on um, machines that wouldn't necessarily, like in the case of Java, have a virtual machine installed. All right, so it makes it so C# projects can be more easily distributed to different platforms. And I really like to think of C# as I've gotten to know it as a sort of improved version of Java, if you could say that in a way, for some of the how it does more capabilities, more cross-platform, easier to code, um, more fluent. So a couple of things I've been mentioned is really .NET Framework versus .NET Core, and this is really important to understand the difference, and I highly recommend you read the article linked to, is that .NET Framework's proprietary. It's used for Windows apps, includes things like the Forum API, and was really what was originally released with C# back in 2002. Okay, so .NET Framework is still used, but it's sort of old, and it really, the features of .NET Framework are really only available for Windows applications. But some of those features of the .NET Framework have been ported to .NET Core, which is open source, cross-platform, includes ASP.NET Core and Universal applications, and was released in 2016. So this is really like sort of a .NET Core you can think of as a sort of a more mature version of Roslyn, which got introduced in 2014, sort of developed in 2015, and then kind of finally released as, I think the .NET Core was done in 2016. So what we're going to try to focus on for our application is really .NET Core, so that the applications we build can work on both the Linux and Windows platform. And you'll see that as we develop the course, or as you go through the course. So what we want to do here is let's just, to help orientate you with other languages that a couple languages you might have seen, or to help you understand the relationship between C, C++, and C#. We're going to go through comparing X versus C#. So X being the language, and C# is what we're going to compare it to, because that's what we're learning. So let's start with C. So let's just kind of understand what C is. So C is the oldest and most widely used of the three. So Dennis Ritchie invented it in 1972 and published in 1978. Basically, Ritchie designed it for a development of a new version of Unix. Up until that point, the Unix operating system used assembly language, which is the lowest level of program readable by a computer. The invention of C revolutionized programming and operating systems forever. So C provided basically a little bit higher level language than assembly language, which was assembly language basically is building bytecode to be run on a machine. So it made it easier because we have programming structures that we're familiar with that we see in our languages like PHP or Java. Those languages have C-like syntax, they would say, with curly braces and semicolons, and that's what you're going to see with C#. So C is still a low-level programming language which performs most efficiently, almost efficiently as assembly code. Now, what we can think of is that C is kind of bare bones and gives you direct access to memory and pointers, and it is doesn't support object-oriented programming. It's really like low level. So it's easier to code in C than assembly language, but you're still dealing with a lot of concepts in assembly language in C with pointers and um, having to manage your garbage collection, which garbage collection is basically deallocating memory for unused variables and unused um, storage in memory, or storage that's been finished to be used. So it's like cleaning out the memory for things you're not going to use, which is garbage collection. So in C, you have to do that yourself. In C++ and when in C# you don't. So C++ was first published in 1985, and basically you can think of C++ as an extension to C, and what it did was add the ability to have object-oriented programming. And C++ is used in servers, and it's used in PC software, and C++ is used a lot in a variety in different platforms, Linux and Mac and PC, and C++ is really widely used language, and it's really like a fourth generation language that builds upon C, that is sort of similar to what you've seen if you've seen Java or even PHP. To it is definitely not like C++, but the syntax is because it uses curly braces and semicolons. Now, if we were to compare C++ and C# and C, essentially you can think that the syntax and the concepts of the variable typing and a lot of these things are basically identical in C#. But if we go back to how a C# application runs, really what happens is that in a C++ application or a C application, you don't need a virtual machine. You don't have .Net Core or .Net Framework or any of these things. You just basically have the application compiled to run on a particular platform, and it's low level enough that you can compile to run a C++ application on different platforms because it's fairly low level and close to machine code. Now, I like to think that a more fair comparison, or more kind of appropriate comparison, is really Java and C#, because both Java used the virtual machine and C# really uses the common infrastructure language specification or runtime with the CLR runtime that provides its virtual machine. I don't call it a virtual machine, it basically is a virtual machine. So if you think about it, it's like if how Java ran or runs, and C++ had a baby, that would be C Sharp. So it's like um, better cross-platform support with C Sharp with multiple languages because of the common language infrastructure. Um, that allows you to write applications of VB.NET and other um, CLI languages. But versus Java, where Java has Java code in the Java virtual machine and doesn't really support any other languages, um, which is sort of not quite because like things like Scala run on the JVM, and there are other languages that they've made to work on the JVM, but it's not really supported by the vendor. They're like independent projects that use the JVM. Now, so really what we have is like a syntax like C, object-oriented programming functionality like C++, a, a runtime environment where we're, in order to run the application, we're running it inside of a virtual machine or um, the common language runtime. So really like to compare Java and also Java is really used in enterprise applications, been used in enterprise applications for years, but C Sharp is obviously newer than Java, and it really, I think, has recently been gaining momentum in development and usage because of the open sourcing of it. Because I think before it was open source, a lot of developers really shied away from it because the only reason to really use C Sharp at that point was because you wanted to make a Windows application. But if you now, because C Sharp is open sourced and supports multiple platforms with .NET Core, I can use C Sharp to write applications that can run in a Linux server, and I can write applications that run on my Windows desktop, and it provides me, the reason why I'm interested in C Sharp really is that it provides me an entry point to have cross-platform applications where I just want to build a server application that I would need to run with a database and on a web server, let's say. But if I want to build a Windows desktop application or a mobile application, I can use C Sharp to do that. And I really can't do those things so easily with Java. Um, and so I think really we're going to find that C Sharp is like the future of a lot of enterprise development, and Java is still going to be around, but I think the versatility of C Sharp and what Microsoft has done by making the CIL or Common Language Infrastructure specification support multiple languages, that the whole idea that Microsoft has is to make their programming languages appeal to the most number of developers and to work in the most number of form factors like mobile and VR and AR and server-based, web-based, cloud-based. So like it's just a way more, and also the portability of C Sharp applications, which we'll find because we can make self-contained executable um, C Sharp applications that are easy to distribute and install on a machine. I think that you're going to find that C Sharp has a lot more capabilities of Java, but that also makes C Sharp kind of somewhat complicated, I think, to understand, because with Java you had just set up the Java virtual machine, run the application in it, you have a jar file, it goes into the virtual machine, it runs it, and that was sort of that's sort of how Java runs. So because of all the capabilities that C Sharp has, it's a more complicated runtime environment that it has. So some of the direct comparison is like, and you can see that they're very similar in a lot of ways. You have C syntax, both are object oriented, they're both both compiled. You have the Java runtime environment, Java Virtual Machine. You have the Common Language Infrastructure .NET for Windows. They're both single inheritance. They're both complete programming languages. You can make any kind of, you really can make any kind of application you want with them. Um, you know, and they're both strongly typed, which means you got to declare your variables and the types, and the types of applications that they can develop are really comparable. You can develop desktop and server-based applications and games and virtual reality, but because of the install base, I think with Windows and tools like DirectX and um, the all the capabilities what Microsoft brings to the table, I think C# has a wider variety and probably an improved quality of application that they can develop. Um, now, some people might be coming from a PHP background and haven't had much experience with any type of compiled language, so I thought that it would be a useful comparison here to look into PHP versus C# a little bit. PHP can be object-oriented, but object-oriented capabilities were added to PHP later, and PHP 7 plus implement pretty good object-oriented support, but prior to 7, object-oriented support was really an afterthought in PHP. So if you're familiar with like PHP 5.5 or something like that, you really didn't get a full experience with all the capabilities of an object-oriented programming language and all the different capabilities that it has. Okay, C# has pretty much all the bells and whistles you'd ever want of an object-oriented language, which we'll talk about later whenever we get more into the functionality in Unit 4. But it's compiled. So what's the difference between interpreted and compiled? So basically, if you've seen a PHP application run, whenever you refresh the browser or you go to a page, it compiles the code. The interpreter interprets the code and generates the output. And so if you want to distribute your PHP application, you got to give somebody the PHP code, and they have to have a PHP interpreter installed on their web server or on the command line in order to run the program that you have. So you have to give them the source code, and they have to have the interpreter installed. So with C#, it's compiled. So that means that the code that you write is turned into a runnable program, an executable file, or a DLL that can be distributed to people to include as a library without revealing the source code. And because it's compiled, that means that you don't have to reveal your code, but it also makes the application run faster, and it enables types of applications that an interpreted language has trouble in many cases implementing. And PHP in particular has trouble with things like event-driven or persistent applications. So like really with PHP, you're not going to make a web server, you're not going to make a chat server. There are projects with PHP that allow this to happen, but it's not the best language to do that. C# really can be used to make a chat server, it can be used to make a web server, it can be used to make applications that run as what they call daemons or persistent processes on a computer. So there's a really wide variety of, there's pros and cons to this though. So just to understand this, in your PHP applications, because the code could compile quickly because it's interpreted, the development speed of a PHP application or a scripting language, and we would extend this to Python, is faster because it's faster for you to get feedback on what did or didn't work on your program to a certain extent with a scripting language or a interpreted languages. With a compiled language, each time you want to run your application, it really has to build it, link it, do all the things with the compiler, and then it's got to run the application. And that it takes more time essentially to see the results of your application, to test your application. So what happens is that there's in a compiled language, there's really a higher penalty for code that's not able to be reused because it took you longer to write it. So you really want to, with a compiled language, you really have to have an emphasis on reusing your code and writing code that works and is modularized and tested so that you can build upon that and reuse that code and make your application and develop the application um, at a good rate, okay, at a good speed of development. Because the compilation process is going to take you more time to work with the application um, or to get feedback on the application. The C Sharp, this in the application, one thing I say, this in the applications that we're building, because they're relatively small, doesn't become a big issue so much. But if you were using a lot of libraries and had to build a larger application with C Sharp, the compilation time may become very, or a decently longer. If your computer isn't very good, you might have a decently long compilation step um, with C Sharp. Okay, so really, it's like I like to think of it as PHP is a great language for making websites, um, web applications. C Sharp is really good for making all different types of applications. Um, I can get a faster development speed with PHP, but I can get a more reliable application with C Sharp because of the being strongly typed, which we'll get to in a second. Both languages are single inheritance, which means that I can only extend a class once. Um, if you'd ever use Python, you can have multiple inheritance with Python, but with C Sharp, you really only can have a parent and child class relationship, and you use interfaces to combine classes together. The PHP is considered a scripting language, and it is, um, and it's really specifically used most of the time for, I would say, 99% of the time to build um, web applications, and also can be used for command line applications, but it's not a really full-featured programming language because it doesn't have any ability really to maintain state if it's required. So like um, basically every time you and it's can be that can be a good thing or a bad thing. Like state in a language is basically persisting data between each interaction of the user. So imagine that like with PHP, every time the script runs, when the script's not running, there's no application running. So, but whenever in C Sharp, when the application is running, if there's no interaction with the application, it's still running. So it can maintain the state between interactions. Just think about how a chat works, where it has to push data to a browser, to like if you or to a web client, so that a chat message comes in and then you get a notification. The reason why you get a notification really is that whatever language was used to make that chat server that can push notifications is that it was able to maintain state of the connection that you have that the client has to that chat server. So that's maintaining state is complicated and you can run into bugs with this when you're working with a language like C Sharp. So you really have to pay attention to if you want to avoid having to maintain the state of an application inside the um, running application. Um, that's why scripting languages, you don't run into state problems so much because they're usually like PHP is stateless because it doesn't save information between runs of the application. Like I said, it's really used for web application. PHP is really used for web applications, and it's weakly typed. So PHP, you know, you can have a one, which is it'll interpret it as an integer, or the interpreter will also be able to take a 1 and interpret it as strings. So PHP is dynamically weakly typed, and this can cause problems in applications, especially ones that have to maintain state, um, because there may be it can be possible to for the PHP interpreter to make a mistake when interpreting the type of content inside of a variable, like the data type inside of a variable. Whereas C Sharp, everything is declared for um, values that are being returned, values that are being used, um, or passed in as parameters, or used inside the function. So everything is what they call strongly typed. So, strings are strings and cars are cars and integers are integers, and it has a bunch of different types, which we'll talk about later when we get into more details about C Sharp. So basically, if you're coming from a PHP background, the syntax of C Sharp is actually going to be pretty familiar to you, with curly braces and semicolons, but the development capabilities and speed of development and need to plan out your application to accommodate the extra time the compilation can take and to plan out your application to use the functionality of the language better, is going to be a sort of a big upgrade for you from PHP to C Sharp. But I think you'll find it exciting because of the variety, the increased variety of applications that you can develop and maturing your programming ability with a relatively easy to use language like C Sharp, because I find C Sharp to be definitely easier than C++ or definitely C, because C Sharp has garbage collection. It deallocates memory for the variables. It does a lot of functionality for you and the syntax and capabilities and libraries built into it are great. So I think you're going to have a really good time with C Sharp. So just a little thing just to kind of highlight the difference between PHP and C Sharp. Um, so here you have a PHP program on the left, and that's a hello world in PHP where you have a web page and you just PHP echo hello world. Whereas in C Sharp, you're going to have the first line is importing the system library, and then we have a namespace, which is, you can think of it like um, on a way, namespaces can be like directories, or they're like a folder for your classes and folder for code. So we have a class which is defining a static method called main. That static method main, it doesn't return anything. That's why it has the void on it. And this is this is gonna print a hello world write line and wait for a response from the console. So this is a C Sharp application. So the I like to just highlight this because there's just more code. Like, they're both doing the same thing. They're both printing hello world on the screen, but you can see how much sort of more code has to be written, because like most of the lines in the PHP program over here that says hello world are just the HTML part. The actual code to write hello world is one line, whereas this requires multiple lines, a namespace, you see a class, like you have a public static void main, or sorry, static void main to run the program. It just, you can see that you're going to have more code required to write a C Sharp application. And again, that goes back to, and that's the compilation issue and the time to development, that you really want to think more about whenever you are developing a C Sharp application, because if you don't design for reusability, it's like a double-edged sword. So you got to design for reusability so that you can sort of speed development by not having to write the same lines of code again and again, or not trying to having to build the same functions again and again. So, or classes, or build the same code. So that's really where PHP and C# are going to be really like apples and oranges together. So like you're going to have a syntax that like you can see that like we have a semicolon at the end of the line, we have curly braces. I don't think there's curly braces that showed on the PHP program, but you know, if you know PHP, it has curly braces. It's going to have a syntax that you're going to be pretty familiar with and going to pick up real quick. But I think that the structure of the program and the necessity to implement object-oriented programming techniques is going to be a challenge for people coming from a PHP background, especially if they really just did basic PHP with echo statements and printing things inside web pages and didn't really ever develop an application using PHP's object-oriented functionality. So let's get started. So we're going to pick up with this next unit, and in this next unit we're going to basically get the IDE set up. So I'm going to come back and work on this unit in a second.